Troubleshooting performance problems. So we've all been there before, having a wonderful, excellent, peaceful day in your office or at your desk, planning for your next project or designing your next database, and all of a sudden it happens. Your phone starts going crazy, your email starts blowing up, your office phone starts ringing off the hook. SQL Server has been brought to its knees. What happened? That's what we're going to look at in this nugget. The goal of this nugget is really just to identify what some of those common problems are and then the tools we can use to find out exactly what the problem is. So we'll start off with the whiteboard just talking about the big problems, the big common problems, which are really going to be I/O, CPU, memory, or concurrency related. It's all about identifying which one it is, because a lot of the times it could be a combination of both. It could look like one, but it's really the other. So that's what we're going to look at here in this nugget. We'll also go over the tools, and we'll come up with a good troubleshooting strategy for when these things occur during your peaceful day. Then we'll jump into the virtual nugget lab. We'll take a troubleshooting demo. I'll show you how to troubleshoot each area individually: I/O, memory, CPU, and concurrency. And at the end here, we'll talk about how to manage your database files. What happens when a file gets too big? If you ever had a log file that's blown up to like 100 gigabytes on a 4 gigabyte database, yeah, what do you do in that scenario? That's what we'll look at there in that demo. So what are some of those common performance problems? Well, high input output. Our disk subsystem doing too much work, especially during peak times or maintenance windows. I/O bottlenecks can be one of the more difficult things to troubleshoot simply because they're usually manifested from memory issues or CPU issues or just plain old poorly written queries or not having a good indexing strategy in place, which is one of the reasons I generally like to look at I/O last, just to rule out any other things that could cause I/O issues. And I'll show you in the virtual nugget lab, we'll look at how we can use some DMVs and the performance monitor to identify if it truly is an I/O issue. Memory pressure can creep up when the system doesn't have enough memory, SQL Server wasn't allocated enough memory, or more commonly, poor database and query design. Lack of memory can also cause high I/O, so this is why it can get tricky when troubleshooting these, but a general characteristic between these is memory pressure pops up randomly. When that rogue query that's requesting all the data from a table sucks up all of SQL Server's memory. And high I/O you can usually tell because it happens at specific times. So if every day at 3 o'clock the system comes to a screeching halt, then you probably have an I/O issue rather than a memory issue. So high I/O, specific times, memory pressure, usually random times. CPU pressure can come from a variety of things, but it's generally going to be those expensive queries or external factors, like an application that's on your database server that's sucking down all the CPU cycles. But CPU pressure can also cause high I/O. Concurrency can cause performance issues, but this is an easy one to identify, because if your I/O memory and CPU levels are all normal, but people are still complaining of waiting and slowdowns in the application, then you can pretty much guarantee that it's going to be a locking and blocking issue. But really, to get the complete picture, you need to take all of these into account when troubleshooting performance issues. What about our tools for performance monitoring? We have a ton of them. We have lots of DMVs across all of these categories, which we'll look at in the virtual nugget lab. We have the performance monitor, which we'll also look at. I'll get you familiar with many of the most popular counters used for identifying each one of these areas. We have the extended events profiler for logging information within SQL Server, execution plans, and we also have the database engine tuning advisor to help us out with query optimization and tuning. We have the data collector, which we can use in Performance Monitor, and SQL Server has its own data collector as well that will compile performance statistics. And then we have the resource governor, which is good for controlling resources at the SQL Server level. And a lot of the times when you're troubleshooting performance issues, you're going to use many of these tools together to paint that picture. So understanding how each one of these works will go a long ways when it comes to troubleshooting anything really, but especially performance. And it always helps when troubleshooting at any level, but especially performance problems, to have a strategy in place. That way, when the crap hits the fan on your beautiful day, you'll be ready to attack the problem. First thing you should do is just define the problem. And this could be tough to do. It could be as general as everything's slow or the system is unresponsive, to as specific as the problem itself. We have a locking problem going on this table. So define the problem first. It's a great starting point. Then determine if it's internal or external. This is huge for performance because it can get us halfway there, especially if we have other things running on our SQL server. Then that could open up a whole other can of worms. So it's good to first identify if it's internal or external. If it's internal, again, you're halfway there. You know it's SQL Server. Then you can determine if it's current, if it just happened first time, or if it's ongoing. And this is where logs can help. It can also help that if this is the first time you've experienced it and you don't know if it's been ongoing, to set up an extended event or to set up performance monitor to run for a day or two to find out if it's a recurring issue or if it's just this one-time thing. Then identify and resolve the problem. Another thing I just want to briefly mention here is how to manage your database files, your MDFs and LDFs. I've gotten many calls in the past of people saying, hey, my log file, it's 80 gigs. What do I do? And it always comes back to, what is your recovery model? Is it full? If it's a full recovery model, everything that's happening in the database is filling up that log file. And if you're not doing transaction log backups, then that log is never going to get truncated. It's just going to keep growing and growing and growing until you run out of disk space. And you wouldn't believe how often that happens. So the moral of that story is to always use a simple recovery model unless you need log backups and you need point-in-time recovery. If that's the case, then use full, but make sure you're doing log backups so your log file will not keep growing or growing. Log backups truncate the log. They don't shrink it, they truncate what's in the log. All that space is going to stay allocated. And generally, shrinking is bad. Now, in the scenario where your log file grew to 80 gigabytes and you've got a 5 gigabyte MDF and then you turn it to simple, that may be okay to reclaim some of that space because you never intended for your log file to get that big anyway. But generally, you want to avoid shrinking. Shrinking has a lot of side effects to it. Specifically, it can cause fragmentation. So that's why if you look at your database and auto shrink is turned on, turn it off. If we don't, SQL Server will put itself in this vicious cycle of expand and shrink, expand and shrink, expand and shrink. So that's bad, and we want to save those resources as much as we can. Also, note that we can use SB space used to see the breakdown. We can see unused space versus reserved space versus index space, and I'll show you how we can use that in the Virtual Nugget Lab. Speaking of the Virtual Nugget Lab, why don't we head over there now? We'll take a look at how we can identify all of these common performance problems. We'll look at how to use a couple of these tools, and we'll see how to manage our database files in that scenario where it's grown to be way bigger than it should be. All right, we made it in. Welcome back. Let's head in to SQL Server Management Studio where we have a troubleshooting project in our solution here. And we're going to start with performance. So we'll start with I/O, show you how we can simulate I/O, and then we'll use DMVs and the performance monitor. I'll get you familiar with a couple of the very important counters that you want to analyze whenever you do come across a performance problem. Now, we're going to start with I/O, but I do want to mention here something that's very important no matter what you're troubleshooting when it comes to performance, and I should have put this in our troubleshooting strategy, but always have baselines. Having a baseline will give us an indication of what's normal. So break out performance monitor, break out extended events, do whatever you need to do to gather data on a slow day, on a busy day, and that way you'll know what normal is, and it'll make it a lot easier to define what abnormal is. So some of the symptoms of I/O problems are going to be a high amount of I/O wait types. I'll show you what that wait type is and what to look out for. Performance decrease during specific times, as I mentioned. Excessive disk latency. I'll show you the counters we can use to discover that, and also the DMV here. Virtual file stats will help us out there. And then always check your SQL Server error logs because they will generate I/O warnings if we have a bottleneck in our disk subsystem. The DMVs we're going to use here in SQL Server to help us identify I/O bottlenecks are going to be the OS wait stats. There are a ton of wait stats out there. Books Online has a complete list, but essentially I'll show you the important ones when it comes to discovering I/O waits. So anytime a thread executes and waits on anything, whether it be the disk or a query, whatever, it all gets stored inside of here. We also have OS waiting tasks, which gives us a real-time view of anything that's currently waiting. And then we have virtual file stats, which is a breakdown of our I/O stats at the file and database level. So these three DMVs can really give us a lot of insight into how our I/O subsystem is performing. And if we scroll down and look at some of these, wait stats, again, this is just a kind of a running total of any time a thread waited on something, it's going to go into one of these categories. And there are 649 different wait types, so that's why it's nice to that we have Books Online as a reference if you want to see what all these do. But essentially, the big ones you're looking for when it comes to I/O is page latch. Anything with a page latch in front of it simply means that there was a delay when writing to the physical database files. So let's see if we can find one in here. I'm sure there is. because it's usually up here. Here's one right here. So anytime you look at this, if you have high values here, meaning there is a lot of weights, then it's a good indication that it's a good starting point anyway for indicating that we have something wrong with our disk I/O. And then you can also use DMOS waiting tasks to get a real-time view of current tasks that currently have that weight type. And you can see we have none in the system right now. And then virtual file stats here, you can pass in a database or you can pass in null for all databases, will tell us our latency stats broken down by file, which is really nice. And in fact, there's a great column here that I ordered descending by called IO stall. This tells us how long in milliseconds users waited for the data to be written to that file. So this could be a good indication. If you have set your baselines here and these are abnormally high, it's a great indication that maybe that disk has too much activity on it, or maybe we need to upgrade disks. Now let's look at some of the performance counters we can use to track I/O. So logical and physical are both their own separate categories. You'll want to track for both of them. And then we have 3 counters: average disk a second read, write, and transfer. These just measure the amount of time in milliseconds it takes for a write I/O request to be serviced by either the logical or physical disk. And ideally, we want this value to be less than 10 milliseconds. Greater than 10, less than 15 is still acceptable. Anything greater than 15 is something we're going to want to look into. Also, idle time. If our idle time is consistently less than 50%, meaning our disks are always busy, then we may want to look at that as well. We have a couple of really simple performance counters to use in the SQL Server category: full scans and index searches. This will give us a good idea of how much extra I/O we're incurring because the lack of indexes or our indexing strategy isn't working and our indexes aren't getting hit. So if our full scans a second is high, we're going to need to troubleshoot. Really, what that's going to mean is breaking out the database engine tuning advisor to get some index suggestions. And then if our index searches is low, it could be an indication that our current indexing strategy isn't working out so well. Let's fire up the performance monitor and see how we can work with some of these counters. So let's go to Start, Administrative Tools, and there is the performance monitor. And let's just expand this all the way. So we can use the classic way of just watching it in real time, adding counters, letting it go. But I like to create data collector sets. We can create a data collector set here, and I've created 4 of them, one for each category we're going to look at. But let me just create a new one here just to show you how to walk through the wizard. So we can create a data collector set here. We'll call this one test. We want to manually add what we're going to track here. We're going to track performance counters. We can add our counters this way. And just to show you here, if we go into SQL Server, access methods, there it is. Expand it. We can scroll down and see our full scans and our index searches. There they are. And then you would just click Add there to add them in. You can also click and get a description of each one of these. Every time you click on something, you get a description. So that's kind of nice. And when you're done, you just hit OK, Next, Finish, and it'll create one for you. Once you do that, you have to start it. So if we start our I/O one here just by right-clicking and choosing Start, it's going to create a new report down here. And there it is. And it will say Collecting Data. Now, I did one and I let it run for a while. And here's what it looks like. So this system that we're on right now is actually configured pretty good because if you look at this, everything's in the ranges that it needs to be in. And it's easier to consume this by looking at the report. But here it is. So our idle time is good. Our average read, transfer, and writes are good. They're all below 0.005, which is ideal. Our full scans are about half every second, while our index searches are about 10. So this is about as good as it gets as far as performance goes on a system. But let's wreak a little havoc here. So while this one's running, I'm going to show you how we can fire up just a simulation utility here to simulate a serious amount of disk activity, and we'll see what happens. So let's head into the file system. We'll go into the C drive, Program Files, SQL Server. We'll look at our instances folder here, into MS SQL, into bin, and just do a search here for SQL IO Sim. There it is. So we're going to simulate some I/O here, and I've already pre-configured this. Created a couple of files here that it's going to read and write to. This one's going to be our log file here, our LDX, and then our MDX will pretend this is our MDF. So this is a great tool for just discovering what your I/O systems can handle. So we're going to hit OK for configuration. We're going to start this simulator up, and it's going to run, and it's going to do crazy things to our system. And while it's doing them, it's collecting the performance data. So I'm going to let that run for a second. I'll be back and we'll analyze the results. All right, so that's been running for a good 5 minutes here. So why don't we stop this? There we go. And now let's also stop. And I started them for everything here so we can look. Let's just stop our IO one here so we can go look at this report. And here it is. Here's what it looks like. So if we switch this to our report here, we can see that now our idle time is above 50%. We know that's bad. Our reads are okay. They're within acceptable range, but our transfers and writes are not. Now, obviously, we use SQL IO Sim here, which is meant to generate a lot of heat, generate a lot of disk activity. But if we were to run this in a production environment over a day or two and we had results like this, then that would definitely be a cause for concern. So these are great counters to discover how your IO subsystem is holding up. And then these access methods are also good, as we saw here, to see how our index strategy, if any, is also holding up. Let's move on to memory and how to troubleshoot some memory issues. The symptoms for memory, again here, system-wide performance decrease and potential for I/O increase. We've got 3 good DMVs to look at here in SQL Server, and then we've got some excellent performance counters along with their acceptable values. So let's start here with the DMVs in SQL Server. We have OSSys info, which just gives us some good information here about current memory, physical, virtual, and committed. And then we can also get some good system information here. And this one I like because it actually gives us a description. So we get total physical memory, available physical memory, and then it actually just tells us available physical memory is high. So that's good. So currently we have no memory issues going on in the system. And then the last one here, OS process memory, is another good one because we've got some good flags in here to let us know if our physical and virtual process memory for SQL Server is low. If both of these are zeros, you're in good shape. Let's take a look at some of those counters. So the first one here, memory available megabytes. This is just a great all-around counter. Especially if we track this over time, we can easily find out what our thresholds are for memory. Buffer manager, buffer cache hit ratio. This is a percentage how often SQL Server can find the data pages in memory as opposed to fetching them from disk. So we always want this to be extremely high. Lazy writes per second is how many pages are flushed from memory outside of the checkpoint process when there's memory pressure. So this value should always be under 20. If it's greater than 20, or if you see it consistently going above 20, then it's a good indication that you'll need to allocate more memory to SQL Server. Page life expectancy, otherwise known as PLE. This is probably the most popular performance counter when it comes to memory for SQL Server. This is the number of seconds a page will stay in the buffer pool without references. So essentially, we want a page to stay in the buffer pool as long as possible because it'll lead to high performance. If a request comes in for data on that page, it can use the cache rather than going to disk, which will help also reduce I/O. Now, the old rule was this value should always be above 300, but that rule was around since the days where max server memory was around 4 gigs. Now, we get a much more than that. So this is going to be memory dependent. One of the greatest modern day formulas I've seen and used to come up with your specific PLE value is take the amount of memory you've allocated to SQL Server. Let's say that was 16 gigabytes. Divide that by 4 and multiply that number by 300. That would give us 1200, and that's a great base. So if our PLE value is below 1200 in this case, it's a good indication that SQL Server does not have enough memory to keep pages in the buffer cache long enough, which, by the way, will also directly affect our buffer cache hit ratio. That's why these two, PLE and the buffer cache hit ratio, are two of the most important and commonly used counters to discover how we're doing with memory in SQL Server. And this last one was actually for the I/O section, but I showed you how to do that using weights. But just to note, you can use this in Performance Monitor as well. There's a counter for it. But let's head back into the Performance Monitor. And I stopped our memory and CPU and concurrency that have been running for a while. If we click on our memory one, this is what it should look like. Now, we've got 2.5 gigabytes here on this system. I've got 1 gigabyte dedicated to SQL, 1 to the OS, and then we've got about 500 and so free. And so that's what it's showing here, 500 available megabytes. But here are the good ones, and these are all just about as good as it gets for these values. Buffer cache hit ratio, 100%. Because we don't have a lot of activity, so anything that's in memory is staying in memory. That's why we have that. But that's good. That's what you want. You want a very high value there. Lazy writes a second, 0, even better. And page life expectancy. Look at that. Pages are not getting flushed out of memory because because memory's not getting turned over. So again, these are about as good as it gets. But these are absolutely what you want to be looking at when you're researching memory issues, because they give you a lot of insight into how SQL is using memory. Let's move on to CPU troubleshooting. So some symptoms of high CPU utilization is when you go into Task Manager and you see all your CPUs pegged. That's a good sign something's going on. I/O increase is always High recompiles, a large number of recompiles can definitely add some cycles to the CPU, and expensive queries, even more so. We have a great DMV, DM exec query stats, that we can use a number of ways. I'll show you how we can use it to discover high amounts of recompiles, and we can also use it to find our expensive queries. And then in the performance monitor side, we've got a couple of really straightforward and simple counters to use. Overall processor time here, this should always be less than 80%. User time, less than 80%, and then kernel time should be less than 30%. If any of these are above, it may be a good indication that we're stressing out the CPU. And as always, when it comes to CPU, you should always look for external things outside of SQL Server that are causing extra cycles as well. Now, let's first look at DMExec query stats. Here's one that just uses query stats. Again, cross-applies it so we can get the SQL out of it. But here we're going to query where plan generation num is greater than 1. That indicates that this query has done more than one recompile, which is a good indication that it may do more. So if we run this, we should be okay on our system here because we haven't really ran any queries, but that's one way to use it. And then you can use it another way here to discover your top 3 or top 5 or top whatever most expensive queries. So here we're just going to order by total worker time, which is essentially processor time. So if we highlight this and execute it, we should have some expensive queries here. This was from our optimizing queries nugget where we wrote that extremely expensive query, and of course that should be the top one because it takes a very long time to run, like at least a minute for every run. So there it is. On the performance monitor side, if we head into CPU and we look at this report and just switch to report here, we can see that our privilege time looks pretty good, processor time looks good, user time, all of them are in good shape. What about concurrency? Well, concurrency, as I mentioned, is pretty much the easy one to troubleshoot, but some good symptoms here are going to be slow throughput, blocking events, lots of blocking events, and then if CPU memory and IO utilization are all normal, but people are still complaining about performance issues, then it could be a good indication that we have some issues with concurrency. We've got a couple of DMVs to discover locks. We have an entire locking nugget to discover what resources are being locked and by what and for how long, so check that out for more info on that. And then on the performance monitor side, very simple here, lock waits a second and then lock wait time a second. These two combined will give you a good indication of if there's locking going on and how severe it is. And we currently have no locking issues going on, so I won't even take you into performance monitor to show you those goose eggs. And one thing I did want to mention here is that you can use the OS performance counters DMV here to view all of SQL Server's performance counters right here in Management Studio using T-SQL. So this is very nice because we can query against it, pull out whatever you want, and it'll just show you the current value. So if you're just looking to see what a quick value is, you don't have to fire a performance monitor to find out. The last thing I want to show you here real quick is what to do if your log file is too big. Well, number one, let's say that you're in the full recovery model, but you're not doing transaction log backups. That's really situation number one. And in that case, we could change our recovery model to simple, so our log file would no longer get bloated. SQL would manage the truncating of it, and then we could shrink that file. We could shrink that file because it was unintentional. We never meant it to get that big. It's not supposed to be that big, so we could shrink it. And just to show you, to change recovery model, very simple. Go into the properties of the database, options, and here's your recovery model. So you would turn that to simple first, then you would shrink the log file. And to give you an example, we actually did this with our log file. We were in full recovery model. I turned it back to simple. And now if we go into our data directory, we can see that our log file is bigger than our entire database. Our log file is 500 megs, while our database is only 400 megs. So what we could do in this case is right-click on the database, head into tasks, head into shrink. We're going to shrink files, and we want to shrink our transaction. We don't want to shrink our data file. That's always a bad idea because, again, that opens it up to fragmentation. So we will do that. We will release the unused space. We should reclaim 98% of it, and it should shrink pretty dramatically here. And look at that. There it is. Now it's down to 1 meg. Another scenario is, let's say we do want the full model, and we just weren't doing transaction log backups. We planned on getting there, but now our log file is huge, and let's say it ran the disk right out. And now the disk is full, and our database won't start up, and we've got all kinds of problems. Well, in that case, what we could do is we could add a new log file to the database, put it on a different disk. SQL Server will recover. It'll start logging to that log file. While that's going on, we could back up the log, which will truncate both logs. Then we could shrink that initial log file, get it back down to a manageable size, and then alter our backup strategy to start doing transaction log backups. That would be another way to recover from a large log file where we would want to stay in the full model. And you can easily add new files. Just go into properties here, go into files, add a new file. Oop, not two new files, one new file. Make it a log file, put it on a different disk, and there you go. You're on your way. Also note you can use SP space use to discover our space breakdown here. So let's switch databases to Nugget Demo DB and let's run this. There it is. Now before, this was a little over a gig. Since we shrunk our log file, we're down to 500 total size, but we still have plenty of unallocated space for SQL to work with, so I won't need to constantly expand our files here. So shrinking in this case didn't cause a big deal because we didn't shrink an MDF. We only shrunk the LDF there. And then it also shows our space breakdown. So we've got this much space reserved for our objects, this much of its data, this much is index, and this is how much we have unused. You can also pass in a table name and get some good stats broken out by table. So here's the number of rows, reserved data, index, and unused. And finally, we have this wonderful undocumented stored procedure called SPMS for each table. We pass in our statement. This question mark acts as a parameter where this stored procedure will fill in each table name in the database. So the result then will be our space used stored procedure ran against every single table. How cool is that? And there's also an SP for each DB as well. In this CBT Nugget, we learned how to troubleshoot performance problems. We started off with a whiteboard just to go over what those problems are. The big ones are going to be I/O, memory, CPU, and concurrency related. We got familiar with some of the tools for working with performance problems and troubleshooting. We talked about a strategy, and we even went over some of the things to think about when managing your MDF and LDF files. Then we jumped into the virtual Nugget Lab. We got a troubleshooting demo. We saw how to use the performance monitor, saw how to use some DMVs, and just generally got familiar with what to look out for each area: I/O, memory, CPU, and concurrency. And at the end here, I showed you how to manage large LDF files. I hope this has been informative for you, and I'd like to thank you for viewing.